We're ready to begin our tech talk today on what's new in Simcenter 3D 2412, and this is part 2. Now, our presenter today is out of our Cincinnati office is Pratik. Pratik is an application engineer for Solid Edge and Simcenter 3D at Prolim. He graduated from Michigan Technological University with a Master of Science degree and specializing in design and FEA. Now the tech talk is yours now.
Good morning, everyone, and welcome to today's Tech Talk on what's new in Simcenter 3D Part 2. This is a continuation of my previous Tech Talk. So some other enhancements that we can take a look at is right here. So we have a new command that is called as the imprint object command. Now, in the previous versions, the user had difficulty managing the coincident edges and faces in the CAD bodies, which would affect your FEM file. So now we have a new command that is called as the imprint object. So what this tool does is it will help you to imprint edges and faces onto the adjacent faces and bodies. What it also does is it will automatically stitch the edges and create a glue coincident MMC using the source and target face pair. Now, why this is important? It's because the users can avoid altering the CAD model by enabling a customer default option which you might have used before called as stitch edges on FEM creation. So let's take a look at this command in action. So I'm going to go into my Simcenter 3D and use this part file. Now, as you can see here, all I have here is multiple sheet bodies here. So let's see if I go and hide one sheet body here. Let's hide this trim sheet. You can see that this trim sheet is not intersecting with my green face and partly with the yellow faces as well. But even if it is doing it, we can still trim it using this imprint object. So let me turn my trim sheet back on, and here I'm going to select all the faces using the box selection. And before I click OK, I have to make sure my stitch edges is turned on so that when it actually trims and imprints it on the faces, those face sections are actually stitched. So that's what this stitch edges option does. And once I click OK, you'll see the difference here. So now when I hide my trim sheet here, you'll see that this face now is divided in two, right? Same thing for this green face. This green face is also divided in two. So this is how that imprint object works. And let's see how we can improve the FEM creation. So let me go back here and create a FEM file. Now before we go ahead, let's take a look at our free edges and stitched edges, which we can see in the FEM file from the model display. So from the model display, I'm going to turn on my free edges and stitched edges. So as you can see here, all of my edges where the object was imprinted are stitched. Same thing for the green face over here. So it saves you a lot of time in manually stitching all of the edges as well. And now I can very easily go ahead and create a 2D mesh here. All I have to do is do a box selection again, specify my element type, the element size, and click OK. That's it. Now a couple of things that you can also check here is, let's see if there are any duplicate nodes, right? So I can come here and check for duplicate nodes, right? As you can see, I get a message that says no duplicate nodes found. So this is how you can improve your workflow to a great extent using the new imprint object command. Let's take a look at the next command that we have here, which is some improvements in the 1D mesh. Now in the previous versions, user did not have an option to create separate meshes for each selected edge, right? So now with this new UI enhancement, the user can generate individual meshes for each selected edge, addressing the previous limitation of single mesh creation. So if you take a look at the screenshot here attached, we have a new option that says create separate meshes, and you have two different options for connected meshes and single collector, right? We also have some enhancements made to the show result. So in the previous version it was called as preview, which is now renamed to show result, which enhances the clarity and some user experience. So let's take a look at this command in action as well. So let me go to my browse and look for the file here. So here what I have is I have multiple faces, and in between them I have these edges where I would like to create a 1D mesh. Now one quick way, as you would normally do to create a 1D mesh, is you can just come here, click on 1D mesh, and select all the edges one by one. Right, so once you've specified this, you can select the element type. Let's do C-beam. Let's do a number of elements. Let's do 10. And now what you can do is you can check this option that says create separate meshes. Now if I choose single collector, all of these meshes, as all of this 5 times 3 15 edges will be in a single collector. But if I choose this to for connected meshes and click OK, what you will see here is that, let me expand this. You have 5 different mesh collectors. So if I expand this first mesh collector, I have 1, 2, and 3 separate meshes in a different collector. Same thing I have for each one of the connected edges. I have a different mesh collector. So this is the improvement in the UI if you would like to use a separate mesh collector for connected edges. So let's take a look at the next one here. So let me go back, and the next one that we have is now you can check for dangling nodes. So in the previous versions, the users could not easily isolate 1D elements which were unconnected. So now we have a new option that lets you check for these dangling nodes, which are unconnected nodes specifically, and you can also create a group of those individual elements and nodes. The users can quickly highlight and review the problematic elements from this group and then fix them. So let's take a look at this example as well. Let me go back to my Simcenter 3D and choose my FEM file here. So in this FEM file, if you take a closer look here, I have a bunch of a bunch of 2D elements and some 1D elements which simulate this bolt, and then we have some other elements. So I have bar elements and RB2 as my spider elements. So now some of these supposedly have some dangling nodes. So now a quick way to check that, like we saw in the presentation, is if you come to this drop down and use this check 1D elements option. Now very easily I can either select or choose from displayed and click on this check elements. So now it tells me that the element 5760 has one dangling node, and 5755 has one dangling node. And now you can decide to delete and recreate that, or just delete the dangling nodes, or you have an option to create element group with the dangling nodes in your simulation navigator right here. So let's go ahead and create a group here. But before you do that, if you simply click on this, it gives you a visual representation, and as you can see here clearly, this blue dot shows that this is the dangling node here for element 5760, and for 5755 I think it's somewhere down there. Yeah, there it is. So this is the dangling node we have. So very easily you can find out based upon the element label, which is which specific dangling nodes you have, and then choose the operations based upon your discretion. So in this case, I can what I can do is very easily create a group, and now that group shows up here like this. So if I click on this group, it will it can show me what is available here. I can do a bunch of different things like show only display for this specific section, and these are the two elements which have the problem. So this is how I can use this check 1D element option to see any unconnected nodes or dangling nodes. Okay, so let's move on to the next enhancement that we have here. So the next enhancement we have here is related to groups. So in the previous version, the automatic highlighting of groups upon object selection could slow down the performance if you're working with complex models. So now to tackle that situation, we have a new command that is like a toggle switch, which can be used to turn off the automatic highlighting of those groups from the customer defaults. So what this does is for users, it can improve the workflow efficiency and responsiveness, and this enhancement helps to minimize processing delays, especially if the project is quite resource intensive. So let's take a look at this command in action. So here, let me go and use an example which has groups. So this is a wing example, and as you can see, I have different groups here, and each time I select a group, this group will highlight. Right now, if this was a very huge FEM file, and if you see some slowness or some delay when you try to move an object or select something, which means your performance has been affected. Right, so in such situations, a user can simply go to his or her customer defaults, then go to pre-post, go to performance, and simply turn off this option. And if you apply, it says that this changes will be affected if you restart your Simcenter session, which would make sense because we are making change to a customer default. So I'll have to close all of these files and reopen my Simcenter 3D. So here, as you can see, I've reopened my Simcenter 3D, and I'll go back to the Wing concept FEM file. And now if I go to the groups and try to select anything, you see it will not highlight that group. It does not mean that it is not selecting anything, it's just that the automatic highlight is turned off. You can still pick and choose what you want to show. As you can see, I just decided to show my spars, and then I also want to show my ribs, or you can do multiple selection where you can select bottom, ribs, and spar and do show only. So this is how the new automatic highlight feature toggle switch works. So let's move on to the next enhancement that we have is the new modify label command. In the previous versions, users were expecting a very fast way to view and reassign IDs for key model entities, which can be nodes, elements, properties, CSS, etc. So now, with the new version, we have a centralized tool which enables for the users to quickly edit uh, the labels for nodes, elements, materials, properties, CSS, and so on. So the tool provides a unified interface to manage multiple entities from a single location. As you can see on the left, we have screenshot of all the entity types that the tool can manage. This simplifies the model organization and improves the efficiency when handling large and complex simulations. So let me go back to my Simcenter 3D and show an example here. So this is a mesh file I have, and what the users would normally do in the previous versions is you would go to Nodes and Elements tab, and if you expand the more, you would come to the label, which was only an option to modify the node label. Then you would have same thing for elements. You would come to this drop down and say, okay, I want to go to label, and you can modify the label, right? But now what we have is a more centralized location in your home tab itself. If you expand this properties group drop down, you will see an object label manager. So this is what the new enhancement is about, where you can modify the label for each one of these. So let's take a look at example here. Let's try to modify something for nodes. I'll select all the nodes here, and I think the minimum value right now it's using is 10,001. So we'll try to use 30,001, right? And hit apply, right? So now that updates, and if I select here, you see this is 30,573, 30,394, and so on. So it's a very quick way to make all these changes for nodes. Same thing you can do for properties or for materials, etc. So a centralized location which you can use to manage your label. So now let's move on to the next enhancements. So the next enhancement we have is the collaborative simulation. So collaborative simulation allows you to link simulation data, for example, loads, boundary conditions, and mesh settings across different simulation files. So what this ensures is it is that the consistency is maintained, and if any changes are made to the entities or simulation data, it automatically updates from source to target. So how does this exactly work? Now let's say for example you start with a source simulation. You will start by defining loads, boundary conditions, mesh settings, and other simulation entities in that master or source simulation file. Then what you do is you link that to a target simulation. Now the other simulation files, so once you have a source and you have target, other simulation files can link to the source using the collaborative simulation framework, and these links are now called as the locked linked entities in version 24.12. The automatic synchronization is amazing. When the source simulation is updated, for example, the loads and boundary conditions are changed, the changes are automatically propagated to the linked targets. So usability is improved immensely. The enhanced UI elements like easier navigation and context menus streamline the linking and syncing process. The collaborative simulation is now ready for all the customers, and this marks the removal of customer unrestricted EAFs. So this is the new collaborative simulation tool from Siemens. The next enhancement we have is the Design Space Explorer. In the earlier versions of Simcenter 3D's integrated Design Space Explorer, it had some restricted heats functionalities. But now in version 24.12, eigenvalues is now supported in addition to mode frequency as both design constraints and objectives. Users can now define design variables directly using the solver specific modeling objects. So now let's move on to our last enhancement in the post processing. So we have some enhancements made to the result probe. Previously, users had to manually reselect settings like result type and location when creating result variables. But now in 24.12, the result variables can now be created straight from the post view display, which will remove the unnecessary steps that we used to do in the previous version. The new variables automatically will adopt the display settings such as data source, result type, location, filters, etc. The users can create the result variable simply by right-clicking in the graphics window or from the post view node. So let's take a look at this in action. So let's go and open an existing simulation file where I have a study ran already. So this is a structural static study, and I'm going to turn on my max principal stresses. And as you would normally do, you would come to the result variables. Here you can see all the result variables created, the result type, location, component, and measure. And like you would do in the previous version, you would create a new result variable from here by specifying the specific filter, what type it is, displacement, stress, if it is nodal or elemental, component XYZ, and so on. But now in the newer version, you can do it straight from the graphics window. If you simply right click here, you get an option to create a result variable, or you can do it from the post view node. From here you can just say new result variable. So you have two different options to do it, right? Before we do that, let's make some changes to our post view, and here I'm going to set my result combination to elements only and make sure that is done. Here I'm also going to compare two different results side by side. So for the first one, I'm going to create a result variable from the node here. So let's do go to new result variable, and this one I'm going to call as max principal stress. So I'll just call as max prin. Specify the CSIS. In this case, I'm just going to use a default CSIS. And as you can see, all these settings are grayed out, which would make sense why. And click OK. Now on the second window here, I'm going to place my minimum principal stresses, synchronize both the views, and in this minimum principal stresses, I can create the result variable from the graphics window, like I said before. And here I'm just going to name it as min principal stresses. Now once you create these, you can very quickly view the result variables. From this option right here, you can see max principal and minimum principal stresses here. So these are some of the enhancements that were made here. Now some other things you can also do is you can go to the result probe and you can use a formula, right? So here what I can do is I can say give me a difference of max principal and min principal. Okay, so I can specify that, close the brackets, and once I do that, I get an output option, and I'll say create an output. And where do I want to create this output? I'll say okay, paste it in this window right here. So now this is a result probe solution, which is the difference of the max principal stresses and min principal stresses, which we have saved using the result variable. So these are some of the enhancements made to Simcenter 3D 2412. So I would like to thank you all for attending today's Tech Talk session, and I'm open to any questions if you might have.